What we're going to transition to in our last hour is from examining the question how we know things, and that great question I want you to all be able to ask people when they're frightening you, which is, how do you know that? To the last hour where we talked about general relativity and quantum mechanics, and how I think those two fundamental bedrock principles of physics have really expanded what we think of as the laws of nature, to really see how God upholds and sustains the universe in a much more intricate and complex way than we thought under Newton. To, in this last hour, talking about some of the issues where we might see at the surface the most friction between religion and so-called methodological naturalism, or that sort of branch of science that limits itself to a study of the world, assuming no divine activity and no God. So the first thing I want to talk about briefly is something you might know a little bit about, which is intelligent design. ID, or intelligent design, is actually a very widely used principle. And it's the concept that you can examine any system or object and evaluate how this item came about. Is it a natural process, or was there some intervention by something that required planning, information, or intelligence? Now, we see a controversy with intelligent design as it's applied specifically to biological life. But the reality is it's used in all sorts of other areas. We might use it in a forensic investigation to determine if somebody died of natural causes or somebody's death was caused. Or in an arson investigation, was this fire natural or was there planning that went into it? Or to be something that should be controversial and yet it's not, the search for extraterrestrial intelligence, which is basically an ID search, right? We're getting a signal from outer space and we're asking, was this signal naturally caused, or was there some kind of intelligence that is behind it, an intelligence about which we know nothing? No human has ever met a form of intelligence from outside our planet. Unless you have. I don't know. Maybe. I haven't. Most people here, I think, haven't. Nobody on Earth has. And yet we have a certain subset of human beings that by faith believe that there are intelligent creatures elsewhere in the universe. They have no evidence for it except probability. And they think it's probable that they should exist, and therefore they have faith that they do. Do you know what you would call that? Kind of a religious idea, wouldn't you? So I really, frankly, from a philosophical point of view, do not see the difference between belief in extraterrestrials and belief in a divine planning intelligence. And yet some people insist that somehow there's a difference. For example, there's a British physicist who wrote a book a few years ago about dealing with this whole issue of the complexity of organic life. How is it possible that we have such highly developed, intelligent life forms on Earth that seem to have come about by a natural process, even though that seems impossible? And he said, granted, it does look as if humans and the other animal and plant life on Earth came about through some kind of intelligence. But we know that it can't have been a god. Okay? Throws that out there. So, okay, just left it. We know there can't be a god. So, what probably happened was, in a parallel bubble universe, there were intelligent life forms who wanted to seed life in other bubble universes that were developing in this thing called M theory, which we might have a chance to talk about later. We might not. Time's getting short. And they seeded the concepts and the laws that would eventually give rise to DNA and to life forms in our universe. This is a physicist, supposedly quite intelligent, and he throws that out there and he simply accepts that we are going to believe what he says, and he is hoping that people like you will not come along and say, how do you know that? We know that there's no God. How do you know that? You're going to posit the non-existence of a God and substitute for that intelligent creatures in a universe that we cannot observe. Okay. So, intelligent design, some of the proponents that I have had a chance over the years to dialogue with and meet personally, William Dembski, who is a mathematician who has really approached the concept of detecting design from a mathematical point of view. Carolyn Crocker, who used to work with the National Institute of Health in the United States, was a quite prominent biochemist, taught at George Mason University, and was fired because she pointed out some of the holes in Darwinian theory that have yet to be filled through scientific investigation. Now, I don't know about you, but I can tell you as a former scientist, there's only one way science makes progress, and that is by identifying the holes in theories so that they can be filled. That's all she was doing. But to even present concerns, holes, issues that have yet to be resolved in Darwinianism was enough to get her fired. Do not share that. It's finished, it's done, there are no problems. Even though any biochemist over 2 beers in a bar will tell you there are big problems that have not been solved. William Dembski, who is the author of Darwin's Black Box, if any of you read that? Yeah, Behe. And Darwin's, the Edge of Darwinism? Yeah, The Edge of Evolution. I've got to meet him a couple of times in person and talk with him and also interview him on the radio. Delightful man, Roman Catholic, great father. He's got I think he had 7 kids when I met him, might be up to 9, I don't know. One of the lines that always stuck with me from one of his books is, it wasn't until he was studying for his PhD in biochemistry that he realized so much of what he had learned was conjecture and not actually well-established fact. And he said, I believe this is a direct quote from his book, he says, I got very angry because my undergraduate and master's degree were based on science that was hardly as well-established as everybody would want. And he gives examples. He says a lot of the evolution that I was taught would be things like, well, trait A evolves into trait B. And then over time, trait B resolves into trait C. And there's a chain then of how you get from A to C. And he'd say, I hate to tell you this, but I'm a biochemist. I'm not interested in A's and B's and C's. Give me chemical formulas. Show me chemical pathways by which an A becomes a B and a B becomes a C. Then I'm interested in talking with you. But what you're doing right now with A's and B's and C's is what we used to call at Waterloo hand waving. You guys familiar with the concept of hand waving? And then we put in a pier that will hold up the bridge. How big the pier will be, how much concrete we're going to use, no idea. But we're going to hand wave and just say, and then the bridge stands up. And then the core of the building gets poured. And then the foundation gets built. He says there's a ton of hand waving that happens in Darwinianism where we just say, we think this happens, but we can't biochemically demonstrate how. So I remember inviting him down to Philadelphia and he gave a presentation on blood coagulation. Blood coagulation requires about 40 cascade biochemical reactions to happen. We take it for granted that we cut our skin and blood starts coming out and then gradually congeals at the surface and forms a scab. He's like, that is miraculous that this happens. Because if you get any one of that chain reaction of biochemical molecules goes wrong, the blood in your veins freezes, it all coagulates, or the blood surfaces and hits the atmosphere and it just keeps flowing until you bleed to death. To get it just right, so that it freezes at the surface but not in your body, is a 40 chemical reaction chain. He says, I want you as an evolutionist to demonstrate for me how you can take that 40 reaction process and boil it down stepwise into one chemical, and then you add a second and that gets you a little bit of blood coagulation. And then you add a third and it gets you a little bit more. But if you're telling me I have to have all 40 for it to work, it can't evolve. Because evolution requires small step by small step. And then he did eyesight, and he does a whole bunch of things. He says these are the things that remain to be solved. Their As scientists, their point is not Darwinism fails because it can't explain these things. Their point is your theory is incomplete if you want us to accept it until such time as it can. They're not saying you can't prove evolution, but what they're doing is saying it's not proved until. So if people are getting angry at them simply for saying, here are the things that are left to be proven, that tells me that this is out of the realm of empiricism and reason and into the realm of what? Form of knowledge. Gut reaction, but it has to be right. As a scientist, I'm not interested in has to be right. I'm interested in show it to me in the math or prove it to me in an experiment. So when it comes to intelligent design, we can do two ways of looking at it. We can look at our DNA as a source of a possible indication of design. Our DNA is basically both a hard drive and an operating system. Those of you who use computers or smartphones know that you have the phone itself, but then you have the software that runs on the phone. So if you just have a phone, that's not making anybody a call, and you're not Facebooking on that. You've got to have an Android system or an Apple OS system or some kind of operating system to make it work. Your DNA is the means by which you can store the operating system, but it's also the operating system itself, the chemical information that is stored in that DNA. So when we're talking about evolution, we're talking about not just gradually over time creating a storage mechanism, but also gradually developing an operating system that can be stored in that storage medium. It's like attempting to evolve not just the computer, but Windows 10 at the same time. Because at every step in the process, this computer you're trying to build has to have some function or some use. If you get a step where there's no improvement in function, nothing happens in Darwinism. So when we first discovered DNA, what we actually discovered is you're now telling me that we have found a way to create something to store information, create useful information, both of which happen at the same time. So intelligent design proponents say, man, if you found a signal coming from outer space, you would be rolling out the red carpet for ET tomorrow if it looked like this. This would be the holy grail of the search for extraterrestrial intelligence. And yet because it's in us, people won't see it. It's a Romans 1 moment. The attributes are there, but sin will not allow us to see what's right in front of our face. From a macro point of view, we can talk about design on a big level, even beyond our bodies and our planet, to the level of the universe and the way the physical laws of the universe appear to us now. All of that gives us information that there was some planning that went into this. It didn't just happen by itself. In fact, Stephen Hawking, this was one of his biggest conundrums that he wanted to try and solve. Why is our universe so perfectly suited for intelligent life? Because for most non-believing scientists, this is annoying. It's a huge problem. Christians, not a problem. We're like, well, of course, because Scripture tells us that the universe is designed for life. This is how God did it in the beginning. But if you don't believe in that book, if you don't believe in that account, you're left with a major problem, which is why is this universe, down to its physical constants, so wonderfully designed to support life? So let's talk about that. What does that design look like? Well, how many of you are familiar with the Copernican principle? Okay, if anyone who's studied apologetics a little bit, you might have heard that phrase. Nicholas Copernicus, of course, was a Catholic priest and a scientist who said, looking at the solar system as a place where planets are going around a central star, the math is much easier to work out than if we have everything going around the Earth. Because of Einstein, we know that everything is relative. And if you want, you can use the mathematics that will describe everything going around the Earth in our solar system. You can do it. The math is incredibly complicated, but it works. If you have all the planets going around the sun, the math becomes very, very simple and very, very elegant. So even in the argument of what goes around what, you can, from a certain frame of reference, say everything goes around the Earth. Just depends what your frame of reference is. But if you want to do the math and you want to send spaceships into space, it's a whole lot easier to have everything going around the sun. The Copernican principle, though, is the idea that once we stopped thinking of everything going around the Earth, there was a sense in which we lost our place in the universe. Humans had really come to think that what made us special is that everything revolves around us. Literally. That's why we are loved and valued by God, because God made it so that everything is centered on the Earth. Now we have somebody telling us that actually the sun is the center of our solar system and not the Earth. Then as time went on, we discovered the shape of our galaxy and discovered that we are not even in the middle of the galaxy. In fact, we're way out in an outer spiral arm of our galaxy, and our galaxy is not even the middle of our supercluster. So more and more, it looked like we are on the fringes. And for secular scientists, they said, aha, see, you thought that we were special and that God made us the middle of the universe. In terms of the actual universe, it looks like we're not all that important. We're way out on the fringes. God doesn't seem to care. And that kind of held till about 20, 30 years ago, when some astrophysicists started asking the question, what if we approach this from the perspective of life? Where's the best place for there to be life in the universe? Is the middle always the best place to be? I can tell you, if you play monkey in the middle, you don't want to be in the middle. The middle is not always where it's at. What if that's the same for our universe? So an astrophysicist by the name of Guillermo Gonzalez, some of you might know him, who was an astrophysicist in Iowa, got fired from the University of Iowa because of his ideas. Even though they were published and peer-reviewed and accepted, they're still accepted by the astrophysics community because it turned out that he was a Christian, and this seemed to imply a commitment to a God. He got fired. He got fired because he was brought up on charges not by a single person in his science department, but by the atheist who was the head of the religion department. He got him fired. It wasn't because of his science, it was because of his philosophy. Anyway, he looked at the galaxy and said, you know what? You don't want to be in the middle of the galaxy. The middle of the galaxy is an absolutely terrible place to be. You know why? It would appear that the middles of our galaxies are giant black holes. Black hole is a place where a star has collapsed all of its matter down to such a small space, such a small volume, that the gravitational attraction of that point is so strong that even light can't escape it. Hence, it's black. And all sorts of wonky things happen near black holes. Stephen Hawking spent most of his career examining them. What happens to time? What happens to information? What happens to all sorts of stuff? So if you're in the middle of the black hole, or the middle of the galaxy, you have got the gravitational tides of the black hole. You've got stars every half to a quarter light year. You've got radiation all over the place. Terrible place to be. Best place to be is out in what he called the galactic habitable zone, which is a space not on the fringes, not in the middle, but in the, guess what he calls it? The Goldilocks zone. Yes, they actually call it that. It's the Goldilocks zone. Not too hot, not too cold, just right. Guess where the Earth is? In the galactic habitable zone. Every solar system also has a habitable zone. The stellar habitable zone is a ring around the star that is the place where water will not boil off and water won't freeze solid. But you're able to have liquid water because, lo and behold, we've discovered that even with Star Trek and Star Wars and all our imaginations about how to make a life form, to have an information storage medium like DNA you need carbon. The carbon has to exist in a liquid form so it can float, which means you need to have liquid water. So you can't have intelligent life on a place where you can't have liquid water. That's why NASA is busy out trying to find these planets that are in the Goldilocks zone around these stars, because that's where they figure intelligent life will be located. It's not enough, though, to be in the galactic habitable zone and to be in your stellar habitable zone. You got to have the right kind of star. Not all stars are created equal. Different kinds of stars give different kinds of radiation. If your star is too small, your habitable zone will be too close to the star, and that means your planet gets tidally locked, like our moon is. That's why we always see the same face of the moon, because it's now at a point where the gravity of the Earth and the orbit of the moon is such that the moon's orbit matches its rotation. If your planet is tidally locked, so it only presents one face to the sun, what happens? You get, like living on the equator on one side and living in Nunavut on the other side. And in between, you have a little thin band, but that's not good enough to be able to have intelligent life. You want to be able to have a mixing of hot and cold, which means you need to keep having your planet rotating. And of course, if the sun is too big, then the habitable zone is way out there and your orbit's all messed up. You need to have the right kind of radiation and the right kind of color to permit things like photosynthesis, so that you get a replenished atmosphere. Otherwise, you use up all the oxygen in your atmosphere and everybody dies. So it turns out not too many star systems have this. It's actually quite rare. How rare? We'll get to that in a minute. So we've already talked about being in the galactic habitable zone, being in the stellar habitable zone, having the right kind of star, one not too big, one not too small. Now we've got to look at our solar systems. You know that we're always worried about getting hit by an asteroid, right? I'm going to get hit by an asteroid. Makes for a great Hollywood movie. Why aren't we being hit by cataclysmic asteroids all the time? We have huge outer gas giant planets that basically act as asteroid sweepers through our solar system. Their gravity is sufficient to keep the big asteroids out where we want them, in the asteroid belt, and clear them out of the path of the inner planets like Mars, Venus, Earth, and Mercury. So to have a solar system where your planet's got time to not be bombarded by giant asteroids, you want to have gas giants in the outer system. You also want to have good spacing between your planets, because if the planets are too close in their orbits, every time one passes the other, it throws one of the planets out of orbit, right? Because of the gravity. So you got to have just the right spacing. All right, let's see where we're at. Galactic habitable zone, stellar habitable zone, right size of star, right kind of star, proper gas giant planets in the outer atmosphere, and orbital distance between the planets. We haven't actually talked about the planet itself. A planet that can support carbon-based life, because carbon molecules, again, are the only ones complex enough to form information storage systems, like our DNA. You've got to have the right kind of atmosphere. Not too much, not too little. The right level of nitrogen and oxygen. Too much oxygen, everything catches on fire and burns all the time. Too little oxygen, nothing can breathe. Plate tectonics. What's going to keep renewing the surface of the planet? Thickness of the crust. If the crust is too thick, you can't get plate tectonics. If it's too thin, everything looks like Hawaii and Iceland. Volcanoes all the time. We'd be like dodging lava flows on our way between Waterloo and Kitchener all the time. You've got to have an iron core. Why an iron core? Generate a magnetic field. The rotation of the Earth and the iron in the middle generates a magnetic field around the Earth, which repels what? The radiation coming from the sun, turns it into aurora borealis and aurora australis down in the south, keeps the radiation from getting out of control. And an axial tilt so that you get seasonal variations. There's a lot of factors. You got to get it just right. In fact, let's do the math. This is what's called the Fermi equation. Anybody heard the Fermi equation? Okay, this comes from Enrico Fermi, who in a discussion once, I think it was at the Jet Propulsion Laboratory, years and years and years ago, during a lunch conversation, just kind of threw out this statement and said, where are the aliens? I mean, we keep talking about these millions of stars in the galaxy and all these planets and everything. There should be life all over the place. Where are they? He says there should be a way of calculating how many planets are there out there that can support life. So he came up with an equation. You take the total number of stars in your galaxy. You multiply by the number of them that are the right kind of star, by the number that are in the galactic habitable zone, by the number that are outside the spiral arms, that have at least one terrestrial planet, that have at least one Jupiter-like outer gas planet to do the asteroid sweeping, that have a stable inner orbit, that contain oxygen, the right mass. Oh, you have to have a moon. Why is having a moon important? Tidal forces. Keeps the oceans, kind of cleansing them. Brings all sorts of things up onto the beaches and then back out again. So having a moon creates tides on the planet. Also very useful for ocean life, which, as we all know, all our life on our planet's tied together. So the right moon, right amount of water, steady plate tectonic cycling, and then, the chance that life appears. Because we're going to throw evolution in here just for fun. Because we don't have a God, so something has to create life. These are incredibly conservative numbers. We're giving people the benefit of the doubt here. This is the highest possible range of numbers we could get. And for our galaxy, the chance of ending up with a planet like Earth, 0.05. There should be 0.05 Earths in our galaxy. Think about that for a moment. So how many galaxies do you need to get an Earth? Well, no. 200 galaxies to get an Earth. Just one. We are in a very unique place in the universe. It is sort of the beginning of the undoing of the Copernican principle. As we know more science, it's actually taken us back to saying, hey, it turns out we're in a pretty special place after all. And Gonzalez and his co-author Jay Richards, went on and said, it's not just that. It turns out that all the things that make life possible on Earth also make it possible for us to do science. I want you to think about that for a moment. All the things that make it possible for there to be life on Earth make it possible for us to do science. The chief example they give is the relationship between our sun, our moon, and Earth. By an astonishing coincidence, the size of the moon relative to the sun during a full lunar eclipse is almost identical. The moon covers the full mass of the sun. That enables us to study the corona of the sun. Otherwise, we would have no idea what the light spectrum is being given off by our sun, because you can't look at it. It's just overwhelming, the amount of energy coming off that. With a solar eclipse, we can calculate what the wavelengths of light are coming off the sun, which means we can figure out what the chemical composition of the sun is, which is why we know what makes a star a star. It's how we know they work. And it's what's enabled us to study other stars in the solar system. And the reason we can see a solar eclipse is because our atmosphere is clear. The way you get a clear atmosphere is with the right percentage of oxygen and nitrogen. It just so happens that the same kind of atmosphere that gives life also enables us to consider the stars and the handiwork of the Lord, like the psalmist says. Otherwise, on most other planets in our solar system, you don't see nothing at night. Venus, total cloud cover. You can't see a thing. Titan, you can't see a thing. So you wouldn't even know that there's a full solar eclipse if you wanted to see it. And he goes on in the book and says, really, going back to intelligent design, You've got to see something going on here, that the same features that enable our planet to sustain you and I enable us to study the universe and understand how it works. Romans chapter 1, the invisible attributes of God are plain. God's constructed a universe where we can see them all. Sin is the reason why we can't. Staring us right in the nose, and we're blind to it. All right, our last few minutes, we're going to talk about bad science. This is the application of methodological naturalism, rather than a strict application of the scientific process. So when we hear people talking about science versus God, I suggest it's a little bit like saying numbers versus mathematics, or heat versus ovens, or neurons versus awareness. Science is the study of the trees. The scriptures give us the picture of the forest. God has given us the ability to understand the mechanics of the universe that the scriptures say He providentially supports each and every day, every hour, including our bodies. So the real conflict, if people want to have one, is not between science and God. It's between a desire to believe that by the study of the trees alone, I can understand the concept of a forest. How can you? You never take the right step back. So I have a little video here. I don't know if our speaker is on. This is getting into the question of the hows and the whys. We've talked about our place in the galaxy. The one thing we haven't really talked about is the fine-tuning of our universe, and that's what we're going to talk about next. This clip, actually, you know what? I'm going to skip right over it because I got so much other stuff to talk about. I'm just going to skip over it. It's an interesting clip. It actually is a demonstration of something that was brought up by a professor at Guelph University, who said, being a human being conscious in our universe and looking at all the parameters that allow our universe to exist in the form that it does, and never asking why it exists that way, is a little bit like being a prisoner who's been condemned to death, who is put up in front of a firing squad, in front of 10 sharpshooters, who are all given rifles that are in perfect functioning condition. All of them shoot, and they all miss. And you walk away alive. And you say to yourself, well, of course I'm alive. Because if I were dead, I wouldn't be here to wonder about being alive. A sensible person might say, how is this possible? How could 10 sharpshooters have all missed that I would still be alive standing here? And I think one of the biggest problems between science and God are the people within the scientific community who refuse to ask that question. And they just say, well, all the guns missed. Aren't we lucky? And the ones who say there's got to be a reason. There's got to be a reason why. Neo-Darwinism. Let's spend a couple minutes talking about evolution. We've already talked about it a little bit. But I don't want you to walk away from here without a few answers to what do we do with people that say evolution is a theory that's been demonstrated. We now understand how it is that all life arose on the earth and how we have the variety of flora and fauna that we see today. First of all, the reality is nobody's figured out where life came from in the first place. Nobody has a clue. We've tried all sorts of different things, lightning and test tubes and gas experiments. Nothing works. So evolution assumes the very first cell. That's sort of like saying we don't know where cars come from, but give me a go-kart and I'll be able to build a car. It's like, well, giving you a go-kart is basically giving you a car. It's like you're saying, if you give me a car, I can build more cars. Well, okay. It's much more clever to invent a car from scratch. But evolutionists say you've got to give me life before I can tell you where all life comes from. So that's what they ask for first. The second thing is that a lot of things that evolutionists talk about, they're violating their own principles. So here's an example. I was listening to a sports show in Houston, Texas years ago, and they were talking about ankles and how all the different bones in the ankle evolved over millions of years, this and that and the other thing. 2 minutes later, they said, the ankle was designed so that it can do X, Y, and Z. Okay, did you get it? And evolutionists do this all the time. They'll say it evolved just magically, this, that, happened, the other thing, and then 2 minutes later, what word do they use? Design. They use the word design all the time because only a fool can look at an incredibly complicated piece of machinery and say, it's not design. Richard Dawkins, atheist extraordinaire, admits this freely. He says the hardest thing for an evolutionist is to keep looking at life and saying, it was not designed, it was not designed, it was not designed. At some point you kind of ask yourself, why am I doing that? What if I assumed it was designed? When I talk about evolution in particular, I often use the acronym FICTION, and I talk about fossils, I talk about irreducible complexity, tuning, information, only natural. This is an hour-and-a-half presentation in and of itself. We don't have time for that today. But I will quickly say, number one, fossils are not proof of evolution. We keep trying to make them that, but they're just not. The fossil record should look one way if our evolution is true, and it doesn't look that way at all. It just doesn't look like it should, like a whole bunch of transitional forms leading from one species to another. All of it is big jumps. Here's one kind of species, and then a totally different kind of species, and then a totally other different kind of species. So evolution is actually not supported by the fossil record. Creationism is, or some form of design. Intelligent design people point to the fossil record all the time and say, but look at this. We go from having no fossils to suddenly an explosion of all these life forms that are buried in the fossil layers, all at once. How do you explain that? Irreducible complexity, of course, was Michael Behe's thing. I've already talked to you a bit about it with blood coagulation. So it's the idea that to make evolution work, you have to break down the changes in an organism to one biochemical step at a time. Maybe if you're really lucky, you get two, and you get lucky. But really, you've got to break it down to piece by piece by piece. Darwin himself said this. He said evolution works on a step-by-step basis. So if you have things like blood coagulation, your retina in your eye that require a multitude of biochemical reactions and you can't reduce them to fewer, you've got an obstacle that you've got to demonstrate a solution for. And so far, there isn't one. Tuning. We didn't talk about this much, but I've implied it. And that is the idea that so many of the constants of the universe, the relationship between gravity and the electromagnetic force, the strong and the weak nuclear force within the atom, Planck's constant, the way that water molecules work, all of this stuff, these are constants that are built into the universe, and if any one of them was off by like a fraction of a percent, human bodies or any kind of body couldn't form, the carbon molecules wouldn't bind, planets couldn't hold together, everything would collapse on itself, there'd be black holes everywhere, and yet somehow we won the lottery. That every one of those cosmological constants is exactly the way it needs to be to sustain a universe. In fact, Fred Hoyle, who is a British astrophysicist, said it almost appears like somebody was monkeying with the design of the universe from the very beginning. Really? Information. I've already talked about this too, but going back on it to refresh your memory. DNA is not just a hard drive. It's also the storage of the operating system. In your DNA, you have letter codes for everything needed to construct the molecules in your body. All the information is there. If you were to pick up a book and start reading it, you would not say to yourself, well, over hundreds of millions of years, ink blots fell on pieces of paper that the wind blew together, and then some glue fell from a tree that bound the pages together. And lo and behold, when I look it up, it contains information. You look at a book and say somebody wrote this, right? Same with DNA. There's an information content. Why don't people see these things? Methodological naturalism. Because they decided from the very beginning that that can't be an answer. And my last quick topic, because I know it always comes up. What about the age of the universe? What about the Big Bang? Okay, well, here's the problem with the Big Bang that Stephen Hawking pointed out in his PhD research. It doesn't actually explain anything. Okay, there was a Big Bang. Where did the bang come from? Why was there a Big Bang? If you can't explain that, you actually haven't explained anything. So he tried all of his life to explain why there was a Big Bang. The one thing Stephen Hawking did succeed in demonstrating, because Scripture would agree with this, is that the Big Bang was not just the beginning of space, it was also the beginning of time, if you believe in this sort of thing. It had to be the beginning of both. Well, we could have said the same thing. St. Augustine in the 400s said, when God created, he didn't just create space, he created time at the same time. So it makes no sense to say, what was God doing before creation, or where was he before creation? Because both of those questions imply space and time, which did not exist. I'm going to rephrase that again, because I know even my kids have been asked this by their friends. What was God doing, or where was God before the creation of the universe? You can't even ask those questions because there was no space and there was no time. And both of those questions involve space, where was he, and time, what was he doing? So they're unaskable questions because we can only ask them in the context of a created universe. The Big Bang, though, has a whole bunch of other problems. Sometimes people talk about how can you believe the universe is so young when stars seem to be so far away? The Big Bang actually has the same problem. There's not enough time to get light and heat exchange between all the stars in the galaxy to give us the background radiation that we see from our telescopes, if the Big Bang is true. One solution to that the physicists try and come up with is what's called expansionism, where for a few seconds the universe is expanding and then it's like somebody pulls out the clutch and throws it into fifth gear. No, pardon me. That happens after. First, it's the universe expanding, and then somebody pulls out the clutch, and the car stalls. And so it stalls for a few seconds to give the heat, light, and everything time to exchange, and then somebody pushes the clutch back in, and the universe starts expanding again. Well, that's convenient. There are a whole bunch of ways, actually, that the Big Bang Theory is monkeyed with by physicists, because really, it's not that robust a model. There's still a lot of stuff it does not explain. Dark energy, dark matter. Don't have time to get into all that, but when you hear anything dark, what they're saying is, we've got to make this fit the model, and what we're seeing does not match the math. And so we're going to invent matter, we're going to invent energy, we're going to invent people pulling out clutches and pushing them back in to try and make the theory work. And I'm going to skip over, because we are running short on time. I'm going to talk about these three things last. So you have Stephen Hawking, who says he's explained where the universe has come from. The universe comes about because there's gravity. Now, you should have learned enough, this is like your final quiz, to be able to answer, to say something after somebody tells you that. Well, of course there's a universe, because there was gravity. Yeah, where does gravity come from? Isn't gravity a thing? Does it have to exist somehow? Where did it come from? One of the ways around that has been to say, well, there's this thing called M theory, which means there's actually multiple universes. It's also a way of explaining quantum mechanics. There's a theory of quantum mechanics that says when you observe the light, it continues as a particle in our universe and a wave in another universe that instantaneously gets created. So you get multiple universes that keep being created every time a quantum event happens. One of my favorite physicists from England said, cheap on assumptions, but expensive on universes. It's Like, the math is easy, but seriously, you want to create an infinite number of universes just to explain quantum theory? Like, there's got to be a better way. Yeah.
It also doesn't even answer the question. It just puts it off.
It does. It just pushes it off, which is why we get Dr. Alan Guth, who finally just threw up his arms and just said, maybe the universe is just one of those things. Why do you guys keep asking this? Maybe we should just let it be. To which I would say, what if there's just God? Why do you keep having to ask about where is God and how is God and this and that? What if God is just one of those things? I offer that modest proposal to you today, that perhaps that is a better answer. Because honestly, the other one is just too convenient. So I want to finish at Job 38, and we're going to have some questions. Then the Lord answered Job out of the whirlwind and said, "Who is this that darkens counsel by words without knowledge? Dress for action like a man. I will question you, and you make it known to me. Where were you when I laid the foundation of the earth? Tell me if you have understanding. Who determined its measurements? Surely you know." If Jesus really is the Christ, then he really did do the miracles that he said he did and that people saw him do. And he really did die on the cross and really did rise again on the third day. If all of that is historically true, was observed by the apostles, then the things Jesus said were also true. So when he goes back and says, "Have you not heard that in the beginning he created them male and female?" Perhaps we should take Genesis seriously. And if Jesus tells us to take Genesis seriously, then we have already a history of where the universe comes from. And if we can then observe the universe, we always observe the data to fit it with how we already know the universe turns out, because we don't have to guess about what happened in the past. The Lord's already revealed it. Methodological naturalists have to guess. They don't know. We don't have to, because somebody who was there has already told us. Thank you all so much. I just threw everything in the kitchen sink at you in the last few minutes. There's a lot of stuff to learn, but I hope that you walk away from this saying, we have nothing to fear from good science. In fact, the more good science that's being done, the clearer it is that the picture we're getting of God in Scripture is in fact far more accurate than the guesses the secular world keeps coming at. Thank you.